Welcome to SUSECON and our presentation about the Access 4.0 project. My name is Dominik and I will be joined by my colleagues Thore, Bahr and Dany Al-Gaaf from Deutsche Telekom to lead us through the presentation. Dany is a key member of the Edge Cloud platform project, which takes care of the infrastructure for the project. Thore, as an account sales engineer, has been supporting Deutsche Telekom for several years and has been involved in the creation of the concept. I originally comes from the consulting and supported the project as a project manager for SUSE topics in the beginning. First, Dany will introduce the project before I tell something about the infrastructure. After that, Thore will explain the automated installation process. At the end of the presentation, we will tell something about the difficulties in the project and show an outlook how it will be go on. That's why I would like to pass the floor to Dany now.
Thank you. So let me give you a short introduction into the SS 4.0 project at Deutsche Telekom. So if you take a look on the fixed access today, that means everything like DSL or fiber to your home, everything that's using a landline. In the back, it's all currently mainly a monolithic solution with a vendor lock. We have usually one or let's say two vendors, but the market is very limited in this area. So if you need to introduce a new feature into this setup, it takes usually years to establish, to test it, to bring it to the customers. And one topic is that it is always a fixed cost scale here. For if you roll out more hardware, you have to pay a very fixed price of that. So that makes always a very intense and very long life cycle for hardware and software products on the setup. So what is the project about? If you take a look on this very vendor-locked and monolithic system on the left side, you see there's a central component called BNG, which is the broad network gateway between the customer and our IP core. And as you can see, there's a very black box underneath covering software and hardware, which is usually from one vendor. The project is about breaking up these parts. That means we break up hardware, for example, into white box switches and common off-the-shelf hardware like normal edge cloud servers. And on the other hand, we also try to break up here the software ecosystem to have more than one vendor and be able to select best-in-class vendor from different sources and make them work together. So the project to do that started around 2016. And if it's rolled out finally, it will affect 25 million customers. That covers customers from Deutsche Telekom, but also from other telco companies. As you know, we sell, each telco provider sells lines also to other ones. And it will be rolled out to 900 locations over Germany. So what is the benefit for a telco to switch from such monolithic systems to a more software-driven telecommunication company? One point is that it's really bringing us chances to innovate. It brings us a very high level of network virtualization and automation. We can make use of software-defined network settings. And on the other hand, it enables us to have a very much shorter time to market with new features, with new products for our customers. Subsequently, the network quality will increase because we have a much higher redundancy and much shorter repair times if we have issues in software and hardware. And this brings also the costs down. It reduces our costs and make it more sustainable in the future for us to provide new features and new services to our customers. And at the end, this breakup gives us also a high level of freedom to choose the best-in-class vendor and have a multi-vendor environment. For example, it allows us on the software side also to make where it's possible and feasible and use open source software. So there are some principles to do this kind of disaggregation between the hardware and software. We separate in the setup the control from the user plane so that you have really different planes to handle, for example, to provide access and provision the customer line and separate that completely from the user plane's data that is moving around. On the other hand, we separate, as I said before, software from hardware and cut those in pieces. That means we could have different vendors for example, switches. We can have different vendors for compute hardware, for storage. Where it's needed, we could even mix on one place multiple vendors. And at the end, to make that work, we have to run everything in cloud-native microservices. So what currently is running is usually, if it's good, it's already virtualized probably, but in most cases, the current software is very often directly on the server and running on bare metal. And what we are doing now is moving it up to have cloud-native microservices that give us also, for example, faster recovery times and make it more effective than before. So here's an overview about what is basically done and how it will be set up. So if you take a look on the left side, you have the customers with their fiber to whatever. It's fiber to home or fiber to the building or fiber to the customer set up on the left side. And you have the devices that are doing that on the end of the customer, and the lines from there will be aggregated and will end up in one of our 900 places that are all over Germany. There we will run basically a virtual BNG. And for us here, from there will be the connection to our IP core. And the control plane is separated here, as you can see, in some standard x86 hardware and classical edge servers, which then run all the software that is needed to subscribe a customer, to authenticate a customer, to provision products to a customer. And on top of that, we have some centralized management that is located in some central data centers and a limited number of data centers, providing everything that is needed to provision systems to manage customers. And on top of that, you have the classical OSS BSS landscape. Next slide, please. So what we are concentrating here in our work together with SUSE is the green area here, and that is basically the control plane currently. Next slide. So you always have the decision if you say, we introduce new software and a new way to work in a software-driven telco. You have always the question, what to do? Is it make or is it buy? So on the one hand, you could do everything on your own. That means you could use your own OS. You could write or make use of an existing management stack out there to run your Linux and your Kubernetes. But on the other hand, that also needs a high level of commitment, and it needs very experienced developers and support engineers, because you have everything from a Linux level down to a Kubernetes, and you need a lot of people that really completely understand the stack to be able to handle it. So you always have then the risk to developing very specific solutions to your issue. And they are usually hard to replace and to manage, and even hard to understand. And you tend to do things you wouldn't do if you have a standard product. At the end, it leads a long-term commitment, as I said before, to the solution, and it also needs very often at the end additional support. On the other hand, you could always buy something. As we try to not get into a vendor lock-in, it needs to be a common off-the-shelf product. It needs to be something that is specific to us, designed and developed. And therefore, we selected or could select the best-in-class solution, but it is important in this strategy to say you don't do any customization to the product itself. You can do customization to the automation and the utilization of the product, but you don't change the product for yourself. You take it as it is. Maybe if you need a feature, you can drive the vendor to add a feature, but you don't change the product on yourself. So in this case, you would benefit from the vendor experience, but also from the experience and the feedback and the reports from other customers. It's a big benefit. And you can, by this, utilize the existing consulting and support of the organization. And that is basically what we did. We decided after doing the first and trying to, for the first POC to go the way to make it on your own, we decided that's not feasible for the future, and we tend to buy something. And after reviewing everything, we decided to go with SUSE products because we have a long standing with SUSE and Deutsche Telekom and know each other and have a good experience. So, and now I would give the floor over to Dominik to give an overview about the infrastructure in this project and how we make use of the SUSE products.
The layout of the infrastructure provides that there is a central management and that manage the edge location, also called point of delivery. The infrastructure requirements were that there is a fully automated process for installing the components, that we are hardware independent and can exchange these if necessary in a later process. Thus, the requirement was also that the components must run natively on the hardware and no virtualization is excluded. The communication paths of the various components are also to run via central API. The edge location consists of at least 3 nodes, and only the SSDs of the servers are available as storage. But let's take a look at the components in central management. Contrary to the requirement, it was decided to virtualize the central components and do the relay on hardware installations for the edge locations. We decided to use the lightweight SLE Micro operation system, which is resource efficient and offers significant security advantages due to its immutability. Only the SUSE manager instances have a slash underneath SOS. Since we expected a large number of clients to be managed, we use a SUSE manager hub concept that can easily handle such a workload. Two Kubernetes clusters based on K3S are also running in the central management. On one cluster, the SUSE Rancher server is installed, which takes over the management of the Kubernetes clusters in the edge locations. On the second cluster, applications are running which, among other things, enable the accessibility of internal components such as the Active Directory, as well as one of the most important components of the SUSE controller. This is not a product of SUSE, but an API based on Python developed for the project. However, the central management does not only consist of SUSE components, because in order to be able to install an edge location later, we need data from a CMDB, the so-called A4 inventory. This is where the central information is located that is needed for the automation installation. In order to access this information, we use the A4 EMS, which provides microservices for the provision of the data. Since we are in an air-gapped environment, the images for building the clusters are fetched from the factory. Like the inventory and EMS, this runs on a central Telekom Kubernetes instance called das-Schiff. The source code for the components is maintained in a GitHub called Magenta CI/CD. Let's now take a look at the edge location. Here there are at least 3 x68 servers from Lenovo, each running a K3S node, which then form a cluster. Longhorn is used to offer the applications a persistent storage solution. Otherwise, there are bottom-of-rack switches and fabrics for network communication in each location, which also run Linux in order to be independent of the hardware. In this project, we not only deliver our software products, but also support them with services. That is why Deutsche Telekom, as the project owner, Radisys as partner to make a product of it, and SUSE are working closely together. We as SUSE provide consulting, 2 dedicated support engineers, and a project manager to manage our resources. Now I would like to pass the floor to Thore, which will explain the installation process.
Yeah, thank you, Dominik, for sharing this. And you also have seen that nearly our whole portfolio is used inside of the product. But as we have to fulfill 900 locations, you can imagine nobody will install this manually. So the automation is the key of this. All these locations, there is no expert located. So you have to do everything automatically. And so we call this a zero-touch deployment. Dany already mentioned the project has started 2016 and it is replacing an existing solution. And so you can imagine Deutsche Telekom has already workflow, automation, and process, and a lot of processes we have to integrate. And here is some background, so main design rules which we have to take into account. So first of all, we have this central inventory. Deutsche Telekom has a basic rule that every item, nevertheless, if it's a hardware or software, is called a network element and has to be managed, or the configuration has to be managed within this central inventory. Then we had the requirement to build up a completely air-gapped installation. Even if Deutsche Telekom is one of the biggest internet provider, the system, because of security, is not allowed to speak to the outside. So we have to make sure that every part which we need inside of the installation can be fetched from these Artifactory storage. And we have to include all the hardware and software. This means as we are using open source software, Deutsche Telekom must be able to replace things. They want to use different hardware, and the project itself will run for 10, 15 years. So the automation must be possible to work with this. And so we need a lot of flexibility on this. And so there is an overall process for such a bootstrapping of such a location. And please don't look at your glasses or your display. Yes, this image is blurry, and because we are not allowed to share all the detailed information about this whole process. But you can imagine it's quite complex, and this is just one view on of this lot of processes. But it's the main process where we as SUSE have just one box. And this box is responsible for translating the function of, okay, this has to be installed in the location and maps this to the technical implementation. And this was a birth state of the so-called SUSE controller. So the SUSE controller is the abstraction layer between the function of so-called A4 bootstrapper. So A4 bootstrapper is responsible for controlling the setup of the whole location, including the hardware and software components. And it's speaking to the SUSE controller in a functional way. One of these calls could be install the nodes with OS and Kubernetes, or update a component, or reinstall something like this. But the bootstrapper has no idea about how to install an operating system or how to configure Kubernetes itself. This is something that the SUSE controller has in this business logic, and the SUSE controller itself maps this request and knows when to talk with Ranger API or with the SUSE manager. And we are using Salt as a base for the configuration engine, so the SUSE controller will create all the SUSE states. And SUSE controller also makes the connection to the outside. So it's talking to the EMS inventory about any changes. He's fetching all the configuration data. It's also talking to all leading infrastructures. So SUSE controller is one part of the automation. But besides this, we are really relying on our standard tools, and mainly SUSE Manager. SUSE Manager itself is able to fulfill the life cycle of a whole server. So we use him for the OS installation. And here we have a central DHCP server running in a PXE environment. On the local side, there's only a DHCP relay which forwards the request to the central area. And we are using Cobbler to create an installation profile for this and using AutoJust as a default network installation method to install the server. We decided not to use an image-based approach because we have to fulfill the requirement of different hardware vendors. So if we get new hardware with new network interfaces, we must be able to cover this. And we don't think that it must make much sense to handle and manage a lot of images for this. So here, AutoJust, which we are using for years now, is our standard. The configuration itself on the node is done by Salt, and this is also part of the SUSE Manager. And so SUSE Manager is responsible for the whole installation. It's deploying the Kubernetes part, and it then gives it in the hand of Rancher to maintain and manage the Kubernetes part. And here we have Fleet as a GitOps approach to maintain the resources inside of the Kubernetes cluster. So we have a lot of tools, and they have to work together with each other. As already mentioned, SUSE controller has the logic how to do this, and we created a workflow which consists out of 3 phases to make such an installation successful. You see on the left side the central services. These are the A4 services like the bootstrapper, the inventory, the Artifactory, and our central services, so Rancher and SUSE Manager. And we have 3 phases called discovery, installation, and configuration. A new server, which is set up in the rack, so the physical hardware setup is finished, it's cabled, the network connection is established, will start with the discovery phase. So in this phase, the main task is to identify the hardware. A small Linux is booted via PXE, so it's just a network Linux. And the task is to examine the hardware to find the serial number and to communicate with the SUSE controller to say, hey, I'm a new hardware, what's to do? And the SUSE controller will now speak with the inventory to see, okay, which role, which configuration is prepared for this machine. And based on this information, it will create an individual installation profile. So all needed services like DNS and DHCP entry and Cobbler profile will be created. And if this is finished, the system will reboot. And we enter the second stage. And this is a default standard AutoJust installation. So we will have here a dedicated profile for this machine. The SUSE controller has decided which OS must be installed. The network configuration, basic network configuration is already created, and the system will be installed. The last step at this stage is the registration at the SUSE Manager. And again, the system will reboot. And now it's the first time that the server will use its own disk to boot from. And now the Salt system is starting and will configuring the machine. Based on the role, Salt states are created by the SUSE controller to make sure that the function is working for this node. So if the role is a Kubernetes cluster, SUSE controller takes care about it to say, okay, first of all, I have to start an initial node. This will init the cluster. And when the second and third node are started, they will join the cluster. They will register this new Kubernetes cluster to Rancher and make everything happen to fulfill the function. You can see it's very flexible, so we can depend and we can react on different hardware types. We can handle different OS types here and different configuration. We also use this installation workflow for setting up the central services. So what's working inside of such an Z900 location can also be used to set up a SUSE Manager Hub, for example, or the Rancher Kubernetes server are used for this automation. But Not only the bring up is important to automate, the automation is used in all areas. So we have seen the bring up service here, the initial installation, but you also include in this area the hardware lifecycle. So how to handle BIOS and firmware updates. We have just a requirement. This has to be done in band. This means the vendor of the hardware must provide a Linux tool which is able to do all the maintenance tasks like firmware or BIOS upgrades. And as we are using SUSE Manager as base, also the patching or the upgrade of software is in the hand of SUSE Manager, controlled by the SUSE controller. And this makes it easy to include all this in an overall release management. So the release which will have different hardware, OS, Kubernetes, and the workload at the end combined in one release and make it sure that it will roll out. With all these automation in place, there is one very important part, and this is testing. You have to test this very, very heavily so that you make sure if you roll out a new change to one of these locations that everything works as expected. This is still ongoing, and we see here a lot of progress. But as it's always, doing this on paperwork is quite easy, but the real implementation shows up some challenges. So this would be a good point to hand over again to Dany to talk a little bit about the challenges we have in this real implementation.
Thank you. Next slide, please. Thank you. So if you take a look on what challenges have we facing or are still facing, one is as Thore already said, one topic is hardware management, and that means you have somehow to update firmware and the BMC, for example. So there is currently no vendor independent solution available at SUSE. So there's no product or nothing included in the SUSE manager directly. So the solution is here to either implement a vendor specific solution. That is something we not really desire. So or to use something that is out there and would be usable. The one example would here the ODIM project. That is something that we currently investigating if it makes sense, and it would be nice if SUSE would offer in the future some solution for that. So you could always implement something in the existing solution, but then you have to take care of really what vendor it is. And another topic for us is, for sure, as you know, we have an existing OSS and BSC landscape and a lot of processes. And as we already said before, the servers are not really managed like a data center server. It's more like a network device, and it's a different process and changes a lot of workflow. And that disaggregation is one of the challenges we have to face and we are currently implementing. So on the other hand, you also have the workflow and the work process on the Kubernetes cluster, for example, that is really doing all the provisioning of customers. And here's important to know that it's partly very old protocols used there, and they are complex, and they are not really, in some cases, fully cloud native, and that requires a very complex network setup. That is a challenge, and it also requires additional development because you don't want this for the future. You want to change that and want to solve it in really cloud native. On the other hand, we have this Las Vegas principle, which is somehow reflecting these situation that you have an air-gapped environment. It's not fully an air-gapped because you need to control it, but these are internal lines of Deutsche Telekom and nothing that is having access to the internet. And that also means that as soon as we lose the connection from our central control unit and the system, that it still needs to work. The customer on this that is already provisioned has still to work, and we have to still offer them the existing line and have to keep it up. That is one that also keeps a lot of challenge to what we are doing. Next slide, please. So let me give a short outlook on where we go in the future. One, the current status, as we said, is that we had a proof of concept, and it has been demonstrated that the products of SUSE can be used, like SLE Micro, SUSE Manager, and Ranger, and that it works for us. It is currently a fully automated and deployment for upgrading the edge cloud system that works. It needs to be further integrated. The next steps are basically migrating also the workload to the new platform from our existing system. and integrate everything into our OSS and BSS landscape and the existing processes that Deutsche Telekom has. One big topic that is currently under investigation and needs to be managed is the design of all the day two operations, like updating, upgrading, everything. As Thore already said, automated testing and verification is a very big topic. We have made their progress, but there are further steps needed. After that, we really have to introduce some kind of training to the people that are really managing this and running it on a daily basis later. And then the plan is to roll it out to the 900 sites in Germany in the next few years. That means rolling out at least 3,600 servers over Germany to manage that and all the switches and so on. Next slide, please. So there are some future topics we have as an outlook that we currently are working on, also together with SUSE. I said before, we have these white box switches. They means that's switches without any OS. You can put an OS on it. Currently, we use an existing product out there that is a little bit outdated. So we are looking for a new version that can be managed within this landscape. And that means that we currently taking a look together with SUSE on if it makes sense to utilize SLE Micro in some way to also manage these spine and leaf switches. The challenge here is that it's proprietary hardware drivers, and we need to clarify how to build and support these hardware drivers. That is one topic. And for the rest, I hand over to Thore to give you further.
Yeah, so because we heard now a great overview about this project, but I guess there are a lot of questions about hey, how is it done technically? And so the outlook is, as this project is still ongoing, we hope that we see you again on SUSECON 23. Here we will provide some more technical deep dives into it. And my personal hope is it will be face-to-face. And yeah, so thank you, Dany, for providing all this information. And thank you to you. And I hope this was interesting for you. And I wish you a nice, whatever it is at this time. And yeah, thank you.